All right, for this video, we're going to start off with our word problem introduction. We've already learned how to translate verbal phrases into algebraic expressions or either equations. So I want to look at actual word problems, real life word problems, but I'm going to start off in chunks. I'm not going to do a word problem that involves an equation solving to begin with. I am just going to set up like maybe one side of the equation. So, an equation has a left side and it has a right side. So either on either side, either the left or the right, you will have an algebraic expression when we're talking about setting up an equation which you have to solve. And then on the other side, it will be equal to some number so you can solve it. We're going to focus on this part today, writing the algebraic expression. And then later on, we'll include the equal to and then whatever it equals to, okay, the actual number that the algebraic expression is equivalent to. But today we're just going to focus, this is going to be our focus, writing the algebraic expression that belongs on either the left or the right. So we're just doing these things in pieces. So I'm going to start off by just using a common sense approach. So let's take a look at the first one. I'm going to label this number 1. Mark has just obtained a job that pays $8 per hour. So that's very important. Let's highlight that. Given this information, what we want to do is write an expression. Now remember, we're just writing an algebraic expression that either will go on the left or right side of an actual equation when we get to a word problem that can be converted to an equation. But for right now, we're going to write an expression to represent Mark's pay for the number of hours indicated. So just common sense. We know he's getting paid $8 an hour. So you're going to pretend like you're Mark, okay? So if you work for 1 hour, of course, you get $8. Well, you got that from $8, your pay, times the number of hours. So you got that from 8 times 1. For 3 hours, Mark will be paid $24, but that's not what I want. I want the expression, the numerical expression that's going to give you the 24. How did we get 24? Well, we took $8, our pay per hour, and we multiplied it by the number of hours, 3. So you should see that you're taking your pay, your rate of pay, and you're multiplying it by the number of hours. And that's going to give you your total pay, okay? All right, so for 10 hours, we know that 8 times 10 is 80, but I want 8 times 10. So from now on, I don't want to see this. I want to see what operation we're using and what numbers we're using to actually produce those, okay? So I want the numbers or the operations, that numerical expression that's in black, the black box. All right, so for 35 and 7/10 hours, we know that's going to be $8 times the number of hours, which is 35.7. Not concerned about what that is right now. I know that will equal something, but I'm concerned about the operation, the numerical expression, okay? It will actually be $285.60, but again, that's not going to be my focus. My focus is writing these expressions. And for 40 hours, it's going to be $8, but he's going to make $8 40 times, which will actually be $320. But again, the focus is on writing the expression, not getting the actual pay. Now, what if it was just H hours? Not 1, not 3 hours, not 10 hours, not 35.7, not 40, but H. H stands for any number of hours. What algebraic expression? So everything up here was what we call a numerical expression. Caden, get Corey started. Anybody that comes in, y'all get them started on what they need to do. Explain it to them, Caden. But I need, since H is a variable, I'm going to have, it's called a variable or an algebraic expression. That's what I want to work my way to, because it's going to involve the variable H. Well, we know it's the rate of pay, which is $8, times the number of hours. Well, the number of hours is unknown. That's why we're calling it H. We can write 8 times H, or I can just mash it together. So this is what I'm looking for. If Mark is getting paid $8 per hour, and we don't know the number of hours, the expression, the variable or algebraic expression that we can write is 8H. Anna, you okay? Do you understand it? Do you need to go back and watch some other videos? My concern is you won't be able to do the homework. Try the homework. It's number 2 on there, the classwork tab. All right, let's take a look at number 2 here. Mark plans to save $25 per week. Okay, so he's saving $25 a week. He already has 100 saved, so that's good. Now, we want to write an expression that will represent Mark's total amount saved after any number of weeks, okay? Or the number of weeks indicated to start off with, but we want to work our way to any number of weeks, which we're going to call W weeks. All right, so after 1 week, what we have saved, well, he already has 100, plus he'll save $25. All right, on week 2, which would be $125. I'm going to go back to that in just a second. On week 2, we know he already had 100, and he'll have saved 50, but the 50 comes from $25 from week 1 and week 2. Okay, so he'll have saved $150. In week 3, he already has 100, but will have saved $25 3 times, or 100 plus 75, which is 175. Okay, so let's take a look at what we're doing. 100 is what he already has saved. Plus, the $25 is his rate of saving per week. But we're multiplying that 25 times the 2, which is the number of weeks, or times the 3, again, which is the number of weeks, okay? So it's 25 times the number of weeks. And that's how we're getting his total amount of savings. So here it's $100, what he already has saved, plus his rate of savings, which is 25, times the number of weeks, which is 12. And that would give you $400, because it's 100 plus 300, which is a total of 400. Again, I'm not interested in the amount saved. I'm trying to write the expression. So this is more so what I'm looking for, okay? This, I'm going to go back up here and look at number at week 1. This can actually be 25 times 1, which is still 100 plus 25, which is how we got 125. This will be 100 plus 25 times the number of weeks, which is 32. That's the expression I'm looking for. And this, where all of these are numerical expressions because they involve numbers and operations, this final expression will be what we call an algebraic or variable expression because it has a variable in it. And that's ultimately what I'm trying to learn. So I'm going to take the same setup. I'm going to take what he already has saved, add to it his rate of savings, which is 25 times the number of weeks. In this case, it's W. Now, this can be written with the 25 and the W written together, Or you can write this as 25W plus 100. Either way. I normally like to write mine this way with my variable term first, but it doesn't matter. Let's take a look at what I'm going to call number 3. Mark has just signed up with DirecTV. The package Mark has chosen is going to cost him $135 a month. However, the company is offering a promotion, so let's talk about what the promotion is. It says, according to the promotion, a $10 discount will be applied to Mark's bill for every referral he makes. So basically, the bill may start off at $135, but we're going to be able to take away $10 for every referral. Basically, that's what it's saying. And then he'll get a new bill because his bill will be decreased. The original bill, $135, will be decreased. We're going to write an expression that's going to represent the monthly bill given the number of referrals below. So if Mark referred one person, we know his bill would go from $135 and would decrease by $10. So his bill would be $125. Or if he had 3 referrals, his bill will reduce by $30, but that's just $10 3 times. 10 for the first referral, 10 for the second, and 10 for the third. Okay? And 135 minus 30 means his new bill or discounted bill will be $105. Again, I'm not concerned about the actual bill. I'm more so concerned about the expression that I'm writing. So we can see that what we're doing is taking 135. We're subtracting the rate of discount, but it's times something. 3 refers to the referrals. So times the number of referrals. And I'm going to go back up here. So 10 is basically, we have 1 referral. It's just 10 times 1. Okay. 1 referral, 3 referrals. This would be 135 minus 10 times 5. Still fitting the same setup. This will be 135 minus 10 times 6. And where, again, these are numerical, this last one involves a variable, so it's variable, or again, what I call algebraic. Somebody's doing lots of typing, and I will tell you right now, I know that's not math. So stay on task for me. So it's 135 minus 10, and the number of referrals in this case is R, so 10R. You could have also written this as negative 10R plus 135, but it probably makes more sense to you to write it like this, starting off with the original bill and taking away $10 for every referral. Okay, let's take a look at 4. All right, Miss Blue is buying granola bars for her students. She already has 16 in her desk. Granola bars are sold in packs of 12, however, okay? So I'm going to buy some more because, of course, 16 granola bars are not going to be enough for my students. I want to write an expression that shows the amount of granola bars Miss Blue would have given the number of boxes purchased. So let's see, how many granola bars will I have given out if I just get 1 box? So let's see, I already have my 16 plus they are sold in packs of 12, so 1 box would have 12, so plus 12. So I could give out 28 granola bars. Again, I'm not really interested in this number, I'm more so interested in the expression. All right, what if I had 2 boxes of granola bars? What could I give out? Well, I could give out the 16 that I already had, plus the 2 groups of 12. In other words, the first box has 12, so I can give out 12. The second box have 12, so I can give out 12 more, which is 2 groups of 12, or 12 times 2. If you wanted to calculate that, that's 24 plus 16, which is I could give out 40 granola bars. Again, I'm not really interested in this. I'm interested more so in the expression. If I had 3 boxes, I could give out the 16 I have on my desk already, plus the 3 boxes of 12, which is just 36, plus 16, which is 52. All right, but as you can see, I'm taking the 16, which is the amount I have already. I'm adding to it 12, which is the amount per box. Keep it till tomorrow. Work on your video. But I'm multiplying that 12 by 2. So it's 12 per box. But then it's times the number. 2 is the number of boxes. 3 is the number of boxes. So I can see that it's 16 plus 12 times the number of boxes. Here is 7. Here is 16 plus 12 times the number of boxes. Here is 12 boxes. All of these, again, are numerical. The last one I want to write is algebraic variable. So it's going to be 16 plus 12 times the number of boxes, which it's B. You can also write this as 12B plus 16. Either one will give you, either expression will give you B number of, X number of granola bars, or a certain number of granola bars, depending on what B is. In other words, depending on the number of boxes. Who had Tyler's work? Hunter's going to explain to you what to do. Let's take a look at 5. Kayla plans to save a third of her check this pay period. So a whole check would be 3/3 of one whole. She's saving a third and spending actually 2/3. She already has $700 saved. So I want to write an expression that's going to represent her total savings given her pay. Okay. So let's see. If her check is only $30, she's not going to be able to save much. Well, she already has $700. Okay. That's a given. So, and then she's going to save a third of her check. Now, if you remember back in the translating variable verbal expressions video, if you have a fraction of, it means you are multiplying. Okay. So it's a third of what? Well, her check. Well, what is her check? Her check was $30. So a third of 30. You think about a third of 30. In other words, you split 30 into threes, you get 10. So she'd be 700, what she already has, plus 10. So if she saves a third of her check, and it's only $30, she'll have $710. All right. What if her check was $90? Well, she still has the 700. Plus, she's going to save not a third of 30 now, but she's going to save a third of 90. A third of 90 is 30. Just divide it by 3 to find the third. So she'll have $730 saved. All right. Now, what if her paycheck was $300? So it's 700 plus a third of her check, which is 300. Well, a third of 300 is 100. So with the 700 she already has saved, plus the 100 she's saving now, she'll have a total of 800 saved. So as you can see, we have the 700, which she already has saved, plus we're adding in a third of her paycheck. I'm going to say paycheck amount. That's how we get her total savings. So here it's going to be 700 plus a third of 1,500. Here it's going to be 700 plus a third. Now, it's no longer a regular number. It's a variable, a third of D. And that's how you write that variable expression. All right, you're going to pause the video and try 6. Is it an emergency? Are you what? How's it going? Not good. Yeah, we're gonna have to go back. So while they're taking their test tomorrow, I'm gonna show you how to go back, and you're gonna watch other videos that I've done. Okay, that's okay. You got it, right? That's negative 28 now. Good one. All right. You got your homework too? Just find something constructive. Y'all find something constructive to do if you finish early. All right, on number 6, it says Zeb's rental car services charge $50. A $50 rental fee. Shh. Plus 25 cents per mile. So they're gonna charge you $50 anyway. Plus they're gonna charge you 25 cents for every mile you drive. Says if Gabriel rents a car from Zeb's business, write an expression that will represent his total bill given the number of miles driven. Well, let's see. If Gabriel doesn't drive at all, well, what are they still going to charge him for renting? Well, $50 is the rental fee. You pay that off the top. Plus, he won't have to pay 25 cents at all. So, because it's 25 cents for every mile. And if it's 0 miles, he's paying 25 cents 0 times. But what if he drives 1 mile? Of course, it's $50 plus the 25 cents for the 1 mile, or $50.25. So it's 50 plus he has to pay the 25 cents 1 time. And I'm going to use that, okay? Because the decimal and the dot kind of look weird. All right, 50. And then if he has to drive 3 miles, he's going to have to pay 50 cents, 25 cents for the first one, the second one, and the third one, and 3/4 is 75 cents. But he's paying 25 cents 3 times. So as you can see, it's 50 plus the 25 cents for every mile means times the miles driven, okay? And let me put a little, I don't like the decimal and the 25 cents and the time sign like that. I'm going to put this. All right, so 50 plus 25 cents times 10, or I can do it this way. Mash it together. 50 plus 25 cents times 50. 50 quarters plus the $50. $50 plus, if you're going to drive 100 miles, you're going to have to pay 25 cents 100 times. But if you drive M miles, you're going to pay the $50. And the quarter, you're going to pay it M times. Now, I prefer to write my variable expression or term first, so we can also write it like that. All right, let's take a look at 7. It says Remy has $30 to spend on candy bars. Suppose each candy bar costs $3, but she only has $30 to spend now. She write an expression to represent the amount of money Remy would have left given the candy bars purchased, okay? So how much does she have left? Well, if she buys 1 candy bar, you're going to have to take $3 from her money, so she'll have $27 left. If she buys 2 candy bars, I know she's going to have to take $6 away. But that's actually $3 twice. $3 for the first candy bar and $3 for the second. That's how we get 30 minus 6, leaving us with $24. If she buys 3 candy bars, well, that's 3 times 3, which is 9. So it's $30 minus the 3 times 3, or 30 minus 9, which is $21. So you should be able to see what's happening. I'm going to go ahead and put my 1 there. I am starting off, I didn't mean to do that. She starts off originally with 30. To figure out what she has left, I put what she starts with. And we take away $3 every time she buys a candy bar. So it's $3 times the number of candy bars. So here will be 30 minus 3 times 5. And here will be 30 minus 3c. You can also write this as negative 3c plus 30. Totally up to you. All right, number 8. Aaliyah bought candy to give to 3 of her friends. She set aside 15 pieces for herself. So she took 15 out because she didn't want to be bothered with them. Okay, to make sure she had 15. Write an expression that will show how many pieces each friend gets, given the total number of pieces that Aaliyah brings. So I know if she brings 30 pieces, first of all, she's going to take 15 out for herself. Okay. Okay. So after she takes that 15 out, then she's going to split the remaining between her 3 friends. So let's see. 30 minus 15 is 15. And then she'll split it between those other 3 people, the last 15 between the 3 people. So each person will get 5 pieces. So this is basically 30 minus 15 split between 3 people. In other words, take the 15 out that she wants. She's keeping it for herself. You got to take that away first. What if she brings 45 pieces? What's 45 minus the 15 she's going to take out? She's taking it off the top. And she'll split the remaining, the leftover, after she subtracts, among the 3 friends. So if she takes 15 from 45, that's 30 pieces left, and she splits that between 3 friends, that's 10 pieces each, okay? All right, so let's take a look at what we have. I have a 30. You all go ahead and pack. And a 45, but these things are staying the same. The 15, the minus 15, and the division by 3. So that 30 represents the number of candy pieces. The 45 represents the number of candy pieces. It looks like what I'm doing is taking the number of candy pieces, subtracting 15, which she's keeping for herself, and then dividing by 3. That's going to give the amount to each. That's supposed to be an N. Amount to each friend. So I'm going to take 60, so take the 15 out, divided by 3. Take 75, take the 15 out, divided by 3. Now take X, that's the number of pieces, take the 15 out and divide it by 3. That's the expression. All right, last one, let's look at 9. Hunter's cell phone company charges $35 a month for phone service, plus 50 cents for the text message. Okay, now it's not really like that, it's unlimited text. Write an expression that could represent Hunter's monthly bill given the number of texts, okay? So what is he going to pay just off the top? Well, he's going to pay that $35 a month. Plus, he's going to pay 50 cents for each text, okay? So he pays $35 off the top. Plus, he pays 50 cents for each text. So that's 50 cents for the one text. So that's $35.50. For 2 texts, he'll pay 50 cents twice, which is $1 plus the 35. But I just want to put the 50 cents twice, which we know that's going to be $36. We'll return my smart board back on. Hit it twice. Here is 35 plus 50 cents 3 times. Here's 35 plus 50 cents 10 times. And here it's going to be 35 plus 50 cents t times. Or you can write it like this. You don't have to put that 0.0. You can just put 0.5. You can cross that 0 out or drop it. Or you could write your variable term first. Up to you. All right, that's it. Thank you, guys.